on discrete time systems, and when we applied the linearity and time invariance on the same systems, we have seen that the output of a discrete time system is convolution of xn and hn. Xn is input, hn is impulse response. This is called as convolution sum. It's called as convolution sum. Now let's see some of the properties of this convolution sum and the methods of evaluation of convolution sum. This we have obtained as summation of x of k into h of n minus k, k going from minus infinity to plus infinity. The first property says that x of n convolved with h of n is same as h of n convolved with xn. So it doesn't matter what is the first sequence and what is the second sequence. The order is immaterial. Mathematically, this means order is immaterial. But when you try to understand the systems, what is it? The first thing, xn convolved with hn is this. Xn is the input, yn is the output, and hn is the impulse response. This is same as, this is equivalent to what? If the impulse response of the system is xn and the input is hn, then also the output is going to be y of n. So the order is immaterial, meaning this. So if you take a system with impulse response hn and excite it with xn, you get yn. The same result you will get if you take the system with impulse response xn and the input with hn, you also get the output yn. Meaning of this interchange, possibility of this interchange is this, with reference to systems. Alright? So also xn or x1n convolved with x2n convolved with x3n. Suppose this is the order, first this convolution and then this convolution. It is same as convolution of x2n with x3n, and so here first you convolve this, then you convolve this. This order also is immaterial. Alright? This property is called as associativity of convolution. And the third one is distributiveness. x1n convolved with x2n plus x3n is equal to x1n convolved with x2n plus x1n convolved with x3n. This is also same. These properties can be easily proved, which we have proved in case of continuous time functions for continuous time convolution or convolution integral. All right. Now let us see the examples, few functions. Now here we have sequences could be of finite duration, sequences could be of infinite durations. We will see convolution of two finite duration sequences, so also of convolution of one finite duration sequence with other infinite duration sequence, and convolution of two infinite duration sequence also. Alright, these are three distinct things that we can see through examples on convolution sum. First we will see the convolution of two finite duration sequences. Before going to this example, like in continuous time convolution or convolution integral, here also I can say xn convolved with delta n. What is it going to be? What is this going to be? X of n. Delta n convolve with delta n. Delta n. All right? U of n convolve with delta n. U of n. Now let's say U of n convolve with U of n. We'll see this example first. What is U of n convolve with U of n? What is ut convolve with ut? It was rt. Rt means the ramp function. T times ut. Here also it will be n times U of n. I am only saying comparing this, but let's see whether it is going to be this or not. Okay, let's prove it. Un convolve with un. Write down the expression summation of n going from or k going from minus infinity to plus infinity, u of k into u of n minus k. It is simpler. It is simpler than integrating. The summation is simpler than integration. This uk makes this k from 0 to infinity. What is the u of n minus k? The u of n minus k is going to be 1 for n minus k greater than equal to 0. That means n greater than equal to k, which means k less than equal to n. So u of n minus k is 1 for k less than equal to n. That means I can write the upper limit as n. The summation of k going from 0, if n is greater than k, then only it is up to n. If n is less than k, then 0. So 0 to n both are 1. What is the summation? What is sum of 1 from 0 to n? No, n plus 1. When n is 0, it's 0 to 0, sum is 1. When n is 1, sum is 0 to 1, it becomes 2. So for n equal to 0, it is 1, for n equal to 1, it is 2, for n equal to 2, it is 3, for n is equal to n, it is n plus 1. This becomes n plus 1 for n greater than equal to 0 and is equal to 0 for n less than 0. Hence, this summation, this integration can be written as, or this convolution can be written as n plus 1 times u of n. Un convolve with un is n plus 1 times un. Whereas it was t when it is integration. Integration 0 to t, 1 dt is t. Whereas summation of 0 to n, 1 is n plus 1. See the difference. So, two infinite duration sequences we have taken, one finite duration sequence with one infinite duration sequence we have taken. Now, let us see how do we convolve two finite duration sequences. U of n convolve with u of n minus u of n minus say capital N. So what is this sequence? This is finite duration sequence. This is infinite duration sequence. So one finite duration sequence, one infinite duration sequence. This is same as u of n convolve with u of n minus u of n convolve with u of n minus capital N. So first function, this we already know the result. What is the result? It's n plus 1 times u of n minus, now find out this result. What is this second sequence? Second sequence is a sequence that exists from n onwards, sorry, 0 to n. U of n minus n is what? N minus capital N greater than or equal to 0. That means n greater than or equal to capital N. One sequence is from 0 to infinity, other sequence is from n to capital N to infinity. So what will be the Fourier transform? What will be the convolution? So write down summation of k going from minus infinity to plus infinity, u of k times u of n minus k minus n. I am sorry. The second function is u of n minus k minus capital N. Now it is important for us to solve the second problem, second part of the problem, which is u of n convolve with u of n minus capital N. This is same as summation k going from minus infinity to plus infinity, u of k into u of n minus k minus capital N. This uk makes this from 0 to infinity. So it's equal to summation of k going from 0 to infinity, u of n minus k minus n. Now let's talk about u of n minus k minus 1. So it is equal to 1. This function is equal to 1 for n minus k minus n greater than or equal to 0. I want to find out values of k. So what is the value of k? K is less than or equal to n minus n. Okay. Now if n is less than capital N, if n is less than capital N, what will happen? That means k is less than or equal to 0. For k less than or equal to 0, this summation won't exist. That means for value of n less than n, this summation won't exist. Alright. So this is equal to 0 for small n less than n. Second function, second convolution is 0 before n less than capital N. However, the second function becomes summation k going from 0 to n minus n 1 for n greater than or equal to capital N. And what is this summation? 0 to n minus n, n minus n plus 1. Is it u of n? No, it is u of n minus capital N, because for n less than 0, n less than n it is 0, so it is u of n minus n. So the convolution of u of n convolved with u of n minus u of n minus n is n plus 1 times un minus n plus 1 minus n times u of n minus n. Okay? Now let's further complicate the matter. We have two sequences that are not one, that are not related to u of n, that are related to something else. Let's take two exponential sequences, a to the power n un and b to the power n un, and let's convolve them. Okay? Is that fine? When you complicate the matter, So let's take x1 n is equal to a to the power n un and x2 n is equal to b to the power n u of n. Go ahead and solve it. So x1 n convolve with x2 n is equal to summation of x1 k convolve with x2 n minus k, that means multiplied by x2 n minus k, k going from minus infinity to plus infinity. This is equal to summation k going from minus infinity to plus infinity a to the power k uk multiplied by b to the power n minus k into u of n minus k. The summation of now b to the power n is independent of this summation. So I can take that out. B to the power n is out of summation. K going from minus infinity to plus infinity, a divided by b to the power k. A to the power k into b to the power minus k can be written as a by b to the power k multiplied by u of k into u of n minus k. Now these two decide the values of k. This is equal to 0 if n is less than 0, and this is equal to b to the power n summation of k going from 0 to n a by b to the power k, which means uk make this 0, u of n minus k took the upper limit to n for the value of k. This we have seen in the convolution of un convolve with un, where the limits are from 0 to n. The same thing I have used. Uns decide the limits on this summation. A and b decides the actual values, sample values. And what is the summation? It's b to the power n. Now a by p to the power k is a geometric series. First term is 1. So 1 minus a by b to the power number of terms. How many number of terms? N plus 1 divided by 1 minus a by b, which is equal to, when you multiply it by this, b to the power n plus 1 minus a to the power n plus 1 divided by b minus a. This is the convolution for n greater than 0. So in general, a to the power n un convolve with b to the power n un will be equal to b to the power n plus 1 minus a to the power n plus 1 divided by b minus a whole multiplied by u of n. This is b raised to n multiplied by 1. There is a b here, which is b raised to n plus 1, or otherwise b to the power n plus 1, you take it here. B to the power n plus 1 in the denominator is same as b to the power minus n minus 1. That multiplied by b to the power n makes it b to the power n plus 1. It is b to the power n multiplied by b to the power minus n multiplied by b raised to minus 1. Okay? Actually it is 1. All right. Convolution equal to 0 for n less than 0 and is equal to this for n greater than 0. These two results are combined into this. How is that coming? Because it's uk multiplied by u of n minus k. Here the limits are from 0 to n. Now if n is less than 0, then what happens? There is no overlap. That is why it becomes 0. All right. Next problem, two finite duration sequences. How do we find out convolution of such two sequences? So how do you write this as? 1 plus twice delta n minus 1 plus thrice delta n minus 2 plus 4 times delta n minus 3. How do you write this as? Delta n minus twice delta n minus 1 minus plus 3 times delta n minus 2 minus 4 delta n minus 3. Now go on convolving sequence by sequence. So is equal to, so x1n convolved with x2n will be equal to delta n convolved with delta n. One by one here. So delta n convolved with delta n plus delta n convolved with minus 2 delta n minus 1. So minus 2 delta n minus 1. Delta n convolved with this plus 3 delta n minus 2 plus minus 4 delta n minus 3. So this is over. First term here and all these terms here, convolution is over. Now take twice delta n minus 1, convolve it with the individuals. So plus 2 delta n minus 1 with delta n. Delta n minus 1. Delta n minus 1 with minus 2 delta n minus 1. Delta n minus 1 with plus 3 delta n minus 2. And minus 4 delta n minus 4. Huh? Delta n minus 2? Not clear? Delta n minus 1, delta n minus 1. What is the value of k here? This exists for k equal to 1. What is this exist for? K is equal to n minus 1. When will these two be equal? When n equal to 2. Both of these two are equal. Delta n, otherwise for all other values of n, the multiplication will result into 0. Only for one value of n for which both this multiplication becomes 1 is what is the value of n? n equal to 2, at which the multiplication becomes 1. So what is the value? This value will be delta n minus 2. This value of delta exists at k equal to 1. This value of delta exists at k equal to n minus 1. This is n minus k minus 1 equal to 0. So n minus 1 is equal to k. All right. The multiplication will be non-zero only when both the arguments exist. This argument exists at k equal to 1. When k is equal to 1, what is the value of n? For k equal to 1, n becomes 2. That is why these two exist at, the multiplication exists at n minus 2. So in general I can say delta n minus k or delta n minus k0 convolve with delta n minus k1. Where will this exist? This will exist at delta n minus k0 plus k1. A generic result for you. So now go back to your example. So it becomes minus, this is right now. So delta n with delta n minus 1 with delta n is delta n minus 1. Delta n minus 1 with delta n minus 2 is delta n minus 2, with obviously the value of the scalar associated with it. This is twice is taken out. So delta n minus 1 with 3 delta n minus 2 is 3 delta n minus 3, and minus 4 delta n minus 3 convolve with delta n minus 1 is minus 4 delta n minus 4, and so on. Plus 3 multiplied by delta n minus 2 minus 2 delta n minus 3 plus 3 delta n minus 4 minus 4 delta n minus 5 plus 4 times delta n minus 3 minus 2 delta n minus 4 plus 3 delta n minus 5 minus 4 delta n minus 6. Combining all the results of delta n, it is delta n, one delta n only. In the entire expression, it's one delta n. How many delta n minus 1? Minus 2 plus 2, gone. So plus 0 times delta n minus 1. How many delta n minus 2? 3 plus 3, 6, minus 2, 4. So plus 4 delta n minus 2. How many delta n minus 3? Minus 4 plus 3 is minus 1, minus 6. How come? Minus 4 plus 6, I am sorry. Minus 4 plus 6 is plus 2 minus 6 is minus 4 delta n minus 3. Delta n minus 4 now, minus 4 minus 12 is minus 16. Sorry, I have to take delta n minus 4, I am sorry. This is 3 3s are 9, 9 minus 4, sorry, yeah. This is minus 8 plus 9 is plus 1 minus 8 is minus 7. Okay? Minus 7, minus 6. Then delta n minus 5. Where is delta n minus 5? First time here. So it is minus 12 delta n minus 5 and plus 12 delta n minus 5. So it is 0. So plus 0 delta n minus 5. And n minus 6 is only 1, which is minus 16 delta n minus 6. This is the result. So the sequence I can write as delta n is 1, 0, 4, minus 4, minus 7, 0 and 16. What is the sequence? sequence is x1n convolved with x2n with the above values. If these are the two finite duration sequences, it results into this sequence. Huh? This is 4. 4 is 3 minus 4 is minus 1. Minus 1 plus 3 is plus 2. I am sorry. So this is one way. There is a simpler way, but before going for that simpler way, let's try to observe the result. Let's observe the result. May I have your attention, please? Very, very important observation. What is the length of the first sequence? 4. Length of the second sequence? What is the length of the convolution sequence? Can you correlate? So in general, you will see in future, and we will prove that. What are we going to prove? The point that I am going to prove is if x1n is of length n1 and x2n is of length n2, then the convolution sequence will be of length n1 plus n2 minus 1. In the example case, first x1n was of length 4, x2n of length also 4. What is x1n convolved with x2n? The length was 4 plus 4 minus 1, which is 7. One more observation. When you are representing the sequence like this, we have assumed that the starting point of this sequence is n equal to 0. That you also can safely assume. But if it is not given, you can assume it. But if it is given, then what? Then whatever. I mean, n equal to 0 could be here, n equal to 0 could be here, n equal to 0 could be here. In that case, what will change is the delta n's, they will change. So here we have assumed that in both cases, n equal to 0 is first sequence. We have assumed safely. And we have got the third sequence, that is the convolution sequence also starts with n equal to 0. Alright. So now this exists from 0 to n minus 1, this exists from 0 to n minus 1. So net sequence exists from 0 to n1 plus n2 minus 2. So the length will be n1 plus n2 minus 1. I repeat whatever I said just now. In this sequence, I have only assumed that it is length n1. From where to where, I did not assume. So second part of this could be if x1n is non-zero. Write down along with me. If x1n is non-zero between L1 and L2, means what? L1 less than equal to n less than equal to L2, and x2n is non-zero between L3 and L4 means what? L3 less than equal to n less than equal to L4. The convolution sequence will be non-zero between L1 plus L3 and L2 plus L4. Now, if this is of length n1 and this is of length n2, with this length, what is n1? n1 is L2 minus L1 plus 1. n2 is L4 minus L3 plus 1. Why that plus 1? Because both side is equal to, less than equal to. So it is L2 minus L1 plus 1, L4 minus L3 plus 1, that is value of n2. Net result will be L1 plus L3 to L2 plus L4. This length is n1 plus n2 minus 1. Alright. So to see the same example once again, the first sequence was from 0 to 3, non-zero between 0 to 3. Second sequence also was non-zero from 0 to 3. The net sequence also is non-zero between 0 to 6, but with a length of 7. 0 to 3 length 4, 0 to 3 length 4, net length is 4 plus 4 minus 1. This is a very important result as regards to linear convolution. This is not the same result as that of a continuous time convolution or convolution integral. There we said if the duration of n1 is duration of x1t is t1, duration of x2t is t2, then the length of the convolution integral will be t1 plus t2. Here it is n1 plus n2 minus 1. This is a difference between a continuous time convolution and the discrete time convolution. Alright, remember this carefully. This can be proved. Can I give this as a proof? I mean, you should try this proof yourself. As an exercise, prove both the things. If you prove the second one, this becomes redundant. Alright? And I am sure if you are able to prove this and if you understand this proof, you understood entire convolution. You don't need to have any problem in solving any other problem. If you solve a generic problem, specific problems can be easily solved. Alright? Let's go to the second method of obtaining convolution. Third and fourth methods are very easy. So let me first go to the second method, which appears to be complex but is not. This is for the purpose of understanding convolution I am doing. Alright? So x1n convolve with x2n. I am only going to expand the convolution sum by substituting the values of k and n. That's all. This is equal to summation of x of k multiplied by x1k multiplied by x2n minus k. K going from minus infinity to plus infinity. So what is this going to be? I will write from 0 onwards first and then 0 backward. So I start here. X of 0, x1 0, x2n. K equal to 0. K equal to 1, x1 1, x2 n minus 1 plus x1 2, x2 n minus 2 plus and so on plus x1 infinity, x2 n minus infinity. Now go backward. This is plus. So the term before this will be x of minus 1, x2 of n plus 1 plus x1 of minus 2, x2 of n plus 2 plus and so on plus x of minus infinity, x1, x2 of n plus infinity. This summation is actually this. This is what we have done when we have solved that finite duration problem. wherein we express the xn, x1n in terms of delta n, delta n minus 1 and so on. All right. So this is the expanded version of this summation. And now, what are these first values? These are sample values. X1 are sample values, and you are multiplying these sample values by multiplying these sample values to what? To the sequences of x1 to the sequences x2. x2n is different, x2n minus 1 is different, x2n minus 2 is different, and so on. So x2n is first, it's a sequence. This is delayed, this sequence is delayed by 1, this sequence is delayed by 2, this sequence is delayed by infinity, this sequence is delayed by minus 1 or advanced by plus 1. Advanced sequence, advanced by 1, advanced by 2, advanced by infinity, which you can do easily. So take the second sequence, go on shifting it. Go on shifting n equal to 0 for that, and you get the second sequence. To each of these sequences you multiply by the scalar values of x1, x1 infinity, x1 minus 2, x1 minus 1, x1 0, x1 1, x1 2, x1 infinity, and then add up all the sample values, you get the convolution. All right. Now for a finite duration sequence, we will see the example with a simpler solution. The sequence is same. We will take same sequences. x1n is equal to 1, 2, 3, 4. x2n is equal to 1 minus 2, 3 minus 4. Very simple method. You have learned this method in school days when you actually learned multiplication of two larger numbers, more than one digit numbers, multiplication of more than one digit number. But the only change that you need to do here is multiply the two numbers 1234 by this number 1 minus 2, 3 minus 4, whatever you call it as. But while multiplication, you multiply these by digit wise and place the number multiplication. So now what you do is multiply this by this, minus 4 by 4, and write down the numbers. Minus 4, 4, minus 4, 3, minus 4, 2, minus 4, without any carries into consideration. So you write this multiplication, it is minus 4, minus 8, minus 12, and minus 16. So first multiplication is over. Then you put a cross here. Then multiply by 3. This becomes 12, 9, 8, and 3. Put double cross. Yeah. 6. Put double cross, then minus 2. So minus 2, minus 4, minus 6. No, it's plus 4. Then it is minus 8, and lastly it is plus 1. So 1, 2, 3, and 4. And then you sum individually without considering the carries. So first number is, the sequence is 1. Next is minus 2 plus 2 is 0. 3 minus 4 plus 3 is 2. Minus 4 minus 6 is minus 10. 6, 4 is plus 10. So it is 0. Minus 8 plus 9, minus 8, minus 7, minus 12 plus 12, 0, and minus 16. Isn't it the same? So linear convolution can be easily obtained. Was there a problem? we did not consider something like this. This 4 delta n minus 3 we did not consider while adding. This becomes 0. So this is actually 0. See, it is addition of delta n minus 3, minus 4 here, plus 6 here, minus 6 here, and plus 4 here. It has to be 0. Alright? And that is correct. So 1 0 2 0 minus 7 0 6 minus 16, that is the correct value. Fourth method, you can consider it to be a tabular method. Once again similar, but with minor modifications. What are those modifications? x1k is 1, 2, 3 and 4. This is k going from 0, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3 and so on. Second is x2 of n minus k for n is equal to 0, 1, 2, 3, 4, 5, 6 and so on. These are the values of n. x2 of n minus k I am going to plot here, right? x2 of n minus k for n equal to 0. That means what? x2 of minus k. What is x2 of minus k? It's 1, minus 2, 3, minus 4. Mirror image. x2 of k will be 1, 2, 1, minus 2, 3 and minus 4. That is x2k. x2 of minus k would be this. But there were zeros here, so this will become 0. All zeros. All other values are zeros. Because only non-zero values are considered. Now you obtain x2 of 1 minus k. What is x2 of 1 minus k? This gets shifted by 1. 1, minus 2, 3 and minus 4. But the multiplication happens only during this area. So multiply pointwise and write down the result here. Pointwise multiplication 1 by 1 is 1. So I will write result here. Next result here, plus 2, minus 2, 0. Next is 1, minus 2 and 3. So it is 3, minus 4, plus 3. 3 multiplied by 1 is 3, minus 4 is minus 1, plus 3 is 2. Next value is this shifted by 3 units towards right. Friends, remember the second sequence is first going to be mirror imaged. When you say x2 of n minus k for n equal to 0, this we have already done for continuous time functions. x2t, x2t minus tau. When t is equal to 0, x2 of minus tau is what? It's a mirror image. And then that gets shifted by one step by step towards right. Here the step is clear, there the step wasn't clear. Find out what is x2 of 1 minus k. If x2 of minus k is here, x2 of 1 minus k is this sequence shifted to my right. Alright? x2 of 1 minus k is this sequence shifted by right by 1 unit. x2 of 2 minus k is this sequence shifted by 1 more unit right. This range is 0 to 3. If you recollect, x1k multiplied by x2 n minus k, summation k going from minus infinity to plus infinity. When I say this, when I am putting this k from minus infinity to plus infinity, I am assuming x1k to exist from minus infinity to plus infinity. In this problem case, our k is varying from what? For x1k, k is varying from 0 to 3. That is why I have written, that is why the important region for the values of k is 0 to 3. So this is the sequence that is x1k, this is the sequence that is x2n minus k. When both of them are multiplied, whatever is the multiplication and summation will be the end result. So step by step we have to obtain x2n minus k. x2 of n minus k for n equal to 0 is this. Is that clear? If x2k is 1 minus 2, 3 minus 4, what is x2 of minus k? This is 0, this is 1, this is 2, this is 3. What is x2 of minus k? x2 of minus k means 1, minus 2, 3 and minus 4. With this remains the value of n equal to 0. If this remains the value of n equal to 0, this will be minus 1, minus 2, minus 3. So this is a mirror image about this for n equal to 0. So x2 of minus k, I am actually saying this should be k equal to 0, this is k equal to 0. When I am trying to find out x of 1 minus k, it shifted towards right, k minus 1 shifted towards right, but 1 plus k shifted towards left. Alright? So using this, I am writing the second sequence. Change values of n, second sequence is changed. x2 of 3 minus k is 4, 3, minus 2, 1. x2 of 4 minus k is 0, minus 4, 3, minus 2. Remaining I am not interested in because they are multiplied by 0 on this side. x2 of 5 minus k, 0, 0, minus 4, 3. x2 of 6 minus k, 0, 0, 0, minus 4, and remaining is 0. So seventh value is x2 of 7 minus k. This is 0, 0, 0, 0. This multiplied by this and this multiplied by this, it becomes 0. This value is 0. What is going to be this value now? So minus 4 plus 6 is plus 2, minus 6 is minus 4, plus 4 is 0. Next value is 0, minus 8, plus 9 is plus 1, minus 8 is minus 7. Am I right? Lastly, it is minus 12 plus 12, 0. And minus 4 into 4 is minus 16. So you get a sequence that is 1, 0, 2, 0, minus 7, 0, minus 16. I am not interested in beyond this. I am interested in only values which are non-zero. Consecutive non-zero values. First non-zero values to last non-zero value. Inside I may have 0 values. Alright? Because this defines the length of the sequence. And it is 7. So this is the second method. Second simpler method. Alright? So that's about convolution. Any question on linear convolution? There is one more simpler method. There is one more polynomial is p of x is equal to 1 plus x square plus x cube plus and so on plus x to the power n. How would I represent this in computer's memory? Can anybody tell me? You have done a course on data structures. wherein you have represented a polynomial. How is the polynomial represented in computer's memory? Yeah, in the form of an array. So you write this as an array P 1 1 1 1 1 1 and last one is 1. What is the size of this? 1 by n minus 1 by n plus 1. 0 to n, 1 by n plus 1 is the size of this array. When the polynomial is something like a0 plus a1x plus a2x to the power 2 plus and so on plus an x raised to n. How do you represent this polynomial? It is represented by a0, a1, a2 and so on up to an. Size is once again 1 by n plus 1. Okay? How do you perform what is known as polynomial multiplication? It's not array multiplication, but there is a peculiar algorithm for polynomial multiplication. What do you do for polynomial multiplication? Remember friends, polynomial multiplication is what is known as convolution with reference to this course. So basically linear convolution is polynomial multiplication, and from polynomial multiplication the third method is evolved. So let's take now polynomial multiplication method for the same problem. Last point before we break. So what is x1n? x1n was equal to 1 2 3 4. This can be represented by p of x1 or p of x, p1x I will write, polynomial representing x1n. 1 plus 2x plus 3x square plus 4x to the power 3. x2n is represented by 1 minus 2, 3 minus 4. What is p2x? p2x is 1 minus 2x plus 3x square minus 4x cube. Now p1x multiplied by p2x. Once again the same. So what is it? This entire thing multiplied by 1. So it is 1 plus 2x plus 3x square plus 4x cube minus 2 multiplied by all this is minus 2x minus 4x minus 6x cube minus 8 x to the power 4. This 3x square multiplied by this 3x square is minus 3 plus 3x square plus 6x cube plus 9x to the power 4 plus 12x to the power 5. And lastly it is minus 4x cube minus 8x to the power 4 minus 12x to the power 5 minus 16x to the power 6. That's all. Go on adding. This becomes 1. 2x minus 2x is plus 0x plus 3 plus 3 6 minus 4 is 2x square plus 0x cube plus minus 7x to the power 4 plus 0x raised to 5 minus 16x raised to 6. And what is this? The sequence represented by this p3x, which is x3n. p3x is x3n, which is what? Which is defined as x1n convolved with x2n, which is equal to 1 0 2 0 minus 7 0 and minus 16. So what did we do? When we are multiplying it by, so when you are multiplying by x, we have shifted this sequence by 1 unit towards right. When you are multiplying by x square, you have shifted this sequence by 2 units right, and so on. So all the methods are almost the same, but with minor difference in understanding. Okay? We will solve a more complex problem in the afternoon session. We will break for now, so-called lunch. How much break you want? Half an hour is enough? 1 hour? Okay.